Happy morning to all. Happy morning. Okay, the last class we learned about the rate law and the rate constant. Today our learning objectives as per the rate law and the rate constant. We are writing the overall rate of the oxidation of nitric oxide. Overall rate of oxidation of nitric oxide. What is about the rate law and what is about the rate constant? What is about the rate law? The rate law, the rate of the reaction depends upon the concentration of the reactant. The rate of the reaction depends upon the concentration of the reactant is about the rate law. Am I right? Here we are saying that one A plus B gives product. Here A power m and B power n. Am I right? B gives product. We should be write the rate law and about the order of the reaction. Okay? And I told you about that what is about the K and what is about the M and what is about the N and what is about the A and B. Everything I told you in the previous class. Okay. Today our planning. How you write the overall reactions of the oxidation of nitric oxide. Okay, anyhow, first you write the equation about the NO molecules on react with the oxygen to form NO2 molecules. Here, having some experimental value that I am giving one value, I am only on tabular column about the NO that is you should write the units also. NO into 10 raised to minus 2 and about the units is mole, liter raised to minus 1. And also NO you should be right. And about the initial rate, we are conducting the 3 experiments. Out of the 3 experiments, we have 3 different values. Okay, anyhow, first reaction, that is the reactant NO and O2. Here, any one of the reactant keeping as a constant. That is the reactant having 2. That means NO and O2. These are the reactant. And next the product is NO2. Am I right? The reactant having 2. One is NO and NO2 gas. Here, any one of the reactant keeping as a constant. Here, and changing the concentration of other reactant. Then we are conducting the experiment. By means of we get a theoretical value or experimental value. 3 values are given. And you should be write the rate for rate 1 for first experiment, rate 2 for the second experiment, rate 3 for the experiment. We get certain equation. Am I right? Then you should be divide the equation 2 by 1 for first value. We get n value. That n value is we get 1, number 1. So it follows first order. Okay? And about you should be divide the equation 3 by 1. And also we get value 2, that is it follows the second order. Then you should be write the overall rate of the reaction. That is 2 plus 1 we get 3. Okay, that is the order of the reaction. Let us we can be write. So one of the important question, how we get the order of the reaction value 3. Okay, and one more. Today our learning objective to learn about the rate of the reaction and about the rate constant of the reaction. The differences between rate of the reaction and also about the rate constant of the reaction. This 2 questions we are going to discussing now. Okay. So please all of you take the note. We can be write how the overall of the reaction. Okay. Please all of you take the note. Before learning today learning objectives, first of all we should be learn rate law and rate constant. What is about the rate law? As I told you, rate law. What is about the rate law? The reaction, the rate of the reaction depends upon the concentration of the reactant. Okay. What is about the rate law? The reaction, the rate of the reaction depends upon the concentration of the reactant. Okay? Okay, the rate of the reaction depends upon the concentration of the reactant. That should be learned thoroughly. Okay, for example, we can take one of the concentration of the reactant, that is, we can consider one of the reaction is Ma plus Nb. Okay, Ma plus Nb is product. Otherwise, we can write this also write Xa plus Yb is product. So all correct. Okay. Anyhow, Ma plus Nb is product. Here, the rate law for this reaction, you should be right. Rate is equal to K into, for this reaction, I am taking this reaction, K into A the power M and B the power N. Okay. This is about the rate of the reaction. Rate. Don't forget that rate. Rate is equal to K into A the power M, B the power N. Here, what is K? K, I told you about that. It is the proportionality constant called the rate constant. What is K? The proportionality constant, otherwise called rate constant. Okay, rate constant or proportionality constant. Okay. Anyhow, what is about the value of M and N represent? M and N. M and N represent the reaction order. The reaction order with respect to A and B respectively. A and B respectively. Okay, here, what is about the M? M and N are the order of the reaction with A and B respectively. Then how can you write the overall order of the reaction? How can you write the overall order of the reaction? How can you write the overall order of the reaction? We are simply adding M plus N. Okay, the overall order of the reaction can be calculated by M plus N. The value of the exponents M and N is the rate law must be determined by experiment. This should be must determined by experiment. The value of exponent M and N, it should be determined by experiment. Okay, only experiment. Experiment. That is, we can be discuss about the oxidation of nitric acid. Okay, oxidation of nitric oxide. Okay, we can be determined by experiment. We are conducting only 3 experiments. Okay, 3 experiments, and it cannot be reduced from stoichiometry. Okay, don't forget that it only can be determined by experiment. The M plus N value can be determined by experiment. Okay, okay. To learn about the rate constant for oxidation of nitric oxide. Okay, the rate constant for the oxidation of nitric oxide. Okay, that the previous we discussed about the rate law and about the rate constant. Already we learned that one. And about today, as per the rate law and the rate constant, we have to prove the rate constant for the oxidation of nitric oxide. That means we should be write there, first we write the equation, that is NO, nitric oxide gas, plus O2 gas gives NO2 gas. Am I right? NO gas plus O2 gas gives NO2, nitrogen dioxide gas. Okay, we should balance the equation. How can we balance the equation? Here having 3 oxygen, they are having 2 oxygen, so make it 2 here. So here make it 2. Now the equation is balanced. Okay, let us consider the oxidation of nitric oxide. The series of experiments are conducted by keeping the concentration of one of the reactant is as a constant. Okay, here having reactant, which are the reactant here? NO and O2 are the reactant and NO2 is the product. Here, keeping the concentration of one of the reactant, any one of the reactant as constant, change the concentration of others. Okay, suppose NO is constant means you should be change the concentration of O2. Anyhow, here the keeping the concentration of one of the reactant as constant. Here I have 2 reactant, one of the reactant as constant and change the concentration of other reactant. Okay. Then anyhow, first of all you should be learn one table column. Okay, that is also given. One of the table column. For which we are conducting some experiment. Okay. 1 or 2, 3 experiment we are conducting. First one is you should be write nitric oxide. Next oxygen. Okay, you should be write the 2. Experiment now. This is experiment. Experiment. Okay. Here nitric oxide NO into 10 raised to minus 2. Okay. Nitric oxide into 10 raised to minus 2 mole liter inverse. Second one oxygen. O2 into 10 raised to minus 2. That also is write mole liter minus 2. Next you should be write the initial rate. Okay, initial rate. Into 10 raised to minus 2. Okay. Initial rate into 10 raised to minus 2. That is mole minus 1 and also minutes raised to minus 1. Okay. Experiment number 1. This value is 1.3. Oxygen value is 1.1. This is the theoretical value. And this value is 19.26. This is the theoretical value. Okay. Theoretical experimental value. Next about experiment number 2. The same nitric oxide is the value is 1.3. And oxygen value is 2.2. Here initial rate is equal to 38.40. Next about the experiment number 3. The nitric oxide value is 2.6. Okay, 2.6. Oxygen value 1.1. Same value. That is the experiment number 1. That's same value. And about the initial rate is equal to 76.80. 76.80. Okay. Which are the values are given as per the experiment? Experiment number 1. Experiment number 1. Here the nitric oxide, that is the value is 1.3, and the oxygen the value is 1.1, and the initial rate is 19.26. 19.26. And also the experiment number 2. Nitric oxide 1.3, oxygen 2.2, and also initial rate of the experiment number 2 is 38.40. And about the third one, nitric oxide value is 2.6, oxygen value is 1.1, and the initial rate is 76.80. First you should be write the rate for NO and O2. NO and O2 rate, you should be write the rate. Okay. For the reactant, rate is equal to K into NO power m O2 power n. Okay, clear? First we should be write the rate for this reactant. Rate K is equal to NO power m and O2 power n. Okay. This is for the experiment 1. For the experiment number 1, experiment number 1. For experiment 1, the rate law is, what is about the rate law? Rate 1 is equal to K into NO power m O2 power n. Okay? So, what is the value? Rate 1. This is the initial rate. What's the value of experiment number 1? Rate 19.26. Okay, 19.26 into 10 raised to minus 2 equal to, and it's about the NO value. What's about the NO value? For experiment number 1, 1.3. 1, this is should write K also. K into 1.3, the raised m, and about the O2 value, how much? O2 value 1.1 n. Clear? And also experiment number 2, for experiment 2, how do you write 2? The rate law. Where is the rate law? Rate 2 is equal to, same, you should write same, K NO m O2 n. Okay? How do you write rate 2? This one. This one, that is, what is about the rate, initial rate? 38.40 equal to 1 K into 1.3 power m and also 2.2 power n. Next about, this is equation number 1, equation number 2. Sorry, equation number 1. Equation number 2. For experiment number 3, for experiment number 3, rate 3 is equal to, rate 3 is how much value? 76.80 into 10 raised to minus 2. You should write the formula. Each time you should write the formula. It's K into NO power m O2 power n. Substitute this value. Rate 3, what is the value? 76.80 into 10 raised to minus 2 is equal to 2.6 em and about 1.1 en. This is third equation. Okay? Now, first you should be divide equation number 2 by 1. Equation number 2 by 1. It was the first step. The second step, you should be divide equation 3 by 1. Clear? What is about the first step? You should be divide the equation about 2 by 1. Next equation 3 by 1. So what is the answer? First of all, you should be write equation number 2. Okay, that is called equation 2 by 1. Equation 2 by 1 equal to, as implies, what is about the equation 2? 38.30 38.40 into 10 raised to minus 2 equal to k into 1.3 m into 2.2 m. What is about the equation 1? Equation 1, 19.26 into 10 raised to minus 2 and k into divided by k into 1.3 m, 1.3 m, 1.1 m. How can we cancel? Then cancel means this we can be cancelled. It's approximately, it's a near value. Approximately its value is about, we can be right 2. Am I right? Approximately we can be written as 2. Okay? And we can be cancelled this term also. Okay, so what is the final value? That is, this becomes 2. 2 equal to, here also 2.2 divided by 1.1. Okay, the total we write having one power. What's that power? That is to write n. Okay? Yeah. That means 2 is equal to 2n. 2 is equal to, because 2 by 1 is equal to 2. So 2 is equal to 2n. That is n is equal to, what is about the n? Therefore, n is equal to what? Here, what's n? N. Here, what is the meaning of n? That's very important. The n is equal to 1. Therefore, the reaction in the first order with respect to O2. The reaction is n. Okay. That means, therefore, the reaction in the first order with respect to O2. N is equal to 1 means it goes to first order. Which order? First order. Suppose n is equal to 2 means it goes second order. Am I right? So here the n value becomes 1. So therefore the reaction is first order with respect to O2. Okay, right? Then you have next one is equation number 3. Okay, equation number, I told you that first one you should be divide equation number 2 by 1. Next one is you should be divide equation 3 by 1. Okay, 3 by 1. Equation 3 by 1. Okay, you should be divide equation 3 by 1. What is about the equation 3? Here, this is the 3. Am I right? This equal, it implies that is 76.80 into 10 raised to minus 2 divided by equation number 1. 19.26 into 10 raised to minus 2. 26 in 10 raised to minus 2. That is equal to equation 3 is a k. Here also we will not write the k. You should be write the k also. Okay, k. Okay, k into 2.6 m and 1.1 n. Okay, divided by, what is about the equation 1? K into 1.3 m and 1.1 n. Okay, clear? Then how can, which are the possibility for cancelling? Here 1.1 and 1.1 can be also cancelled. Easiest way. And this also approximately near value. You can be right out of 1970 means that is approximately equal to 4 value. We can be easily cancelled. Am I right? So we can be right. 4 is equal to 2.6 divided by 1.3 the whole m. Okay. Therefore, this also that we can written as approximately equal to 2. So 4 is equal to 2 m. Okay. 4 is equal to how much? 2 m. Here we can be say the value m is 2. So m is 2 means it is the second order with respect to NO. Okay, second order with respect to NO. So n is equal to 1 means it is what? It is first order with respect to O2. N is equal to 1 means what is that one? It is the first order with respect to O2. Here m is equal to 2 means it is a second order with respect to NO. Okay. So what we can be write? How can you take the overall reaction value? The rate law is rate 1 equal to K into NO 2 and O2 1. How the NO2 becomes? How the NO2 becomes? Here NO2 becomes, what is the reason? The second order with respect to NO is how much? 2. So the value M becomes 2. That is NO becomes 2. And about O2 becomes 1. Here the O2 becomes 1. So it should be right O2. So what is the overall? What is the overall order of the reaction? Overall order of the, we can be right. The overall order of the reaction. The overall order of the reaction. That is 2 plus 1. 2 plus 1. 2 plus 1. Okay. Is equal to 2. Is equal to 2 plus 1. So what's the value? 3. Okay. What's the value? 3. This is the rate constant for the oxidation of nitric oxide. Okay, have it out. Okay. So this is one of the important question. Try to learn this question. Okay, all of you should learn this question. You should. If you are writing 2 times, return practice is very easy for you. Next about we can learn what are the differences between rate and rate constant. Differences between rate of a reaction and rate constant of a reaction. One of the very important question, repeating board exam question. Very important question. Rate of a reaction. Rate constant of a reaction. Okay, differences between rate of a reaction and rate constant of the reaction. We can be say the first point we can be say it represent the speed. Okay, that means the reactants are converted into product at any instant. Okay, the rate of the reaction represents speed. Okay, speed. Okay, the reactant are converted into products at any instant. Here it is a constant. Rate constant means constant. Proportionality constant. Proportionality constant. Okay. First point. It is a proportionality constant. Can you learn the first one? It's one of the 3 mark, very important question. 3 mark question, very important. It represents, what is the first point? The rate of the reaction represents the speed. Okay, the speed. Okay, it represents the speed. The reactants are converted into product at any instant. At any instant. What about the rate constant of the reaction? It represents the proportionality constant. Okay, the proportionality constant. Next about second point. It is measured. That is the second point. It is measured as decrease in the concentration of the reactant or increase the concentration of the product. Okay, it is measured as decrease the concentration of the reactant or increase the concentration of products. Okay, here it may be decrease the concentration of the reactant or increase the concentration of the product. It is equal to the rate of the reaction. Okay, it is equal to the rate of reaction when the concentration of each of the reactant unity. Okay, unity. Can you learn? It's a very important question. Can you learn this one? What is about the second point? It's a very important question. Okay, differences between the rate of the reaction and the rate constant of the reaction. Whatever may be the question paper, there is a differences between the question is very important, very compulsory question. Whatever may be the lesson, one differences between is compulsory question. It was must question. Okay. Okay. Anyhow. First question, what is about the first point? Not first question, first point. The rate of the reaction represents the speed of the reactant. Here, the speed. The reactants are converted into product at any instant. The reactants are converted into product at any instant. The rate constant of the reaction is a proportionality constant. Here represents speed. It represents constant. Okay. Speed constant. Okay, clear? Here, the second point, it is measured as decrease the concentration of the reactant or increase the concentration of products. What is about here? Rate constant. It is equal to the rate of the reaction when the concentration of each of the reactant is unity. Clear? Next about the third one, it depends the initial concentration of the reactant. Third one, it depends on the initial concentration. Here, reaction. Here it does not depend. Okay. Here it is depend. Here it does not depend. Okay. It does not. It does not depend the initial concentration of the reactant. It's a very important question. Okay, very important question. Now only you should be learned. Okay, very important. Differences, the 3-mark question. The differences between the rate of the reaction and the rate constant of the reaction. The rate of the reaction and rate constant of the reaction. Very important 3-mark question. The rate of the reaction and rate constant of the reaction. First point, it represents the speed. It represents a proportionality constant. Okay, it represents the speed. It represents the proportionality constant. It represents the speed. The reactants are converted into product at any instant. This the first point is over. The second point, it is measured as decrease the concentration of the reactant or increase the concentration of product. It is measured as decrease the concentration of reactant or increase the concentration of product. That's second point. And what about the rate constant? Second point, it is equal to the rate of the reaction when the concentration of each of the reactant is unity. It is equal to the rate of the reaction when the concentration of each of the reactant is unity. What is the third point? Rate of the reaction, third point. It depends on the initial concentration of the reactant. It represents the initial concentration of the reactant. Here it does not depend the initial concentration of the reactant. Okay. Anyhow, today I am giving this question the assignment. Okay. Now many of them are not writing the assignment. Try to learn one question per day. Okay. Try to learn. Okay. If you are learning one question means one day one question we should be learned. For 1 week, if you are learning means at least you are learning 5 questions or 6 questions or 7 questions. We can be easily learn. Okay. So try to learn one question per day. Okay. So anyhow, all of you please write the assignment question. Okay. The differences between assignment. Differences between rate of a reaction and rate constant of a reaction. Okay. Once again I am saying that please try to write the assignment on each day. Okay. If you are learning one question one day means it is very helpful for your studying purpose. Please all of you should write the assignment all the days. Okay. Thank you all of you. Thank you. Have a nice day.